Alright, today's only video is going to be over number 9. It says write a cosine equation for this particular graph. So what I want you guys to do right now is I want you guys to think about what would a typical regular cosine wave look like. It typically looks like this, where right here you are at 0, 1, and where does it finish? It finishes all the way at 2 pi, comma 1. All right? So that's what your typical cosine wave looks like. So what I'm going to do is I want you to understand this is y equals the cosine of theta. I'm just going to call it y equals the cosine of x. But if I made an equation, y equals negative cosine of x, now it would actually start at 0, negative 1, go up and go back down and finish right here. And this would finish at 2 pi, negative 1. And we just start at 0, negative 1. So right here, if we look at this graph, we can interpret it two different ways. Okay? What I want to do is I want to interpret it as a negative cosine graph to start, and then we'll interpret it as a positive cosine graph. So right here, what I'd like you to do, I'd like you to put a point right there. And this right here, if you think of the halfway point, is right here at 3 pi, so it's going to finish right over here at 5 pi. So I'm going to make it start at pi and finish at 5 pi. That's what I want you to do to start. So I'm going to write y equals a cosine b theta minus c plus d. I'm going to write a equals, b equals, c equals, and d equals to get things started. When I'm interpreting a graph and trying to build an equation that goes with it, what is the very first thing that I typically always start with? Which letter? A, B, C, or D? I actually start with D, but that's okay. But you can start with A, but I typically start with D, which means I start with the midline. I always start with the midline. So right now, my midline is at y equals a negative 1. So right here where it says D, just write in a negative 1. That's the line that cuts right through the middle of that graph. Now, you're right. The next thing I do, I always do the amplitude next. So right now, how do we determine the amplitude? Well, we go from the midline. From the midline, you go the distance going up, or from the midline, you go down. Either way, you're looking for that distance. So how far up and how far down? It's going from 1 to negative 1 to a negative 3, and negative 1 to a positive 1. So 2. Now, being that I said I was going to interpret this graph as a negative cosine graph, I'm going to make my a value negative 2 in this particular case. Because I'm saying it looks like this graph right here. So right now I'm choosing it to be a negative 2. Now the amplitude by itself is just 2. Alright, the next thing I'm going to find is the period. That's the next thing I'm going to find. So I'm going to go over here, I'm going to write the word period. Okay. And the period is the distance basically between where it starts to where it finishes. So I'm just going to do a double arrow here. Maybe you guys can see, if you're watching the video, like, what the heck is he talking about? What is the distance between where it starts and where it finishes? 4 pi, right. So put period equals what? 4 pi. I need to know that. My period is 4 pi. And what's the formula for the period?
2 pi over b.
Right, 2 pi over b. So 2 pi over b equals 4 pi. I'm going to place that over a 1. Then I'm just going to take a little time and energy and do a little cross multiplication, just like my daughter's doing in 7th grade right now. She's learning how to do that old cross product thing. So we have 4 pi times b equals 2 pi times 1, which is just 2 pi. So what am I going to have to divide both sides by? 4 pi. So these cancel out, and b is 2 pi divided by 4 pi. So once again, these pi's cancel out, and 2/4 reduces to 1/2. So what I want you guys to understand, for the b value, right over here, for b, just put 1/2. That's what your b value is going to equal. Now here's the cool news. Here's the great news. If you wanted to in your journal, if you wanted to write, hey, when I have a period of 4 pi, my b value always equals 1/2. You guys can set it up. By the way, I'm just letting you know, in a sine function and a cosine function, if the period is 4 pi, the b value will always be 1/2. If the period is pi, the b value will always be 2. If the period is 2 pi, the b value will always be 1. So that's just a little hint. Hopefully you can kind of see the pattern of how it works. You're like, oh, that makes it a little bit easier. But you don't have to do that. If you want to, have to do it the hard way, you can do that too. Now, the last thing we need to talk about, I'm going to scoot over just a little bit. Not too far though. There we go. We need to talk about the phase shift. That's the tough. If there is a tough one. The phase shift. Okay. So there's a formula for the phase shift, and the formula is C divided by V. But what we have to figure out first, we have to know what this phase shift is. So the phase shift, everybody. Typically, does the cosine graph typically start at pi? Where does it usually start at? It usually starts over here at 0. So look right here. I'm going to look at this closely. Normally, my cosine graph, if it was a negative cosine graph, would start here. But now it starts here. So this distance right there, that's what you call the phase shift. And you can clearly see the distance between here and here. What is my phase shift equal to? A distance of pi. So I'm going to take that, right? I'm going to say my phase shift is equal to what? It's equal to pi over 1. Now the only thing I'm going to do differently is now I know what my value for b is. What am I going to replace for my little letter b? Yeah, 1/2. Very good. So what am I doing? I'm taking c over b, but what did I replace it with? I replaced it with this what? This half. So I just plug it in right there. All right. You're right. So when we cross multiply, Austin said c equals half of pi. C times 1 is c. Half times a pi gives us half of pi. Now I'm going to write that, everybody. I'm going to write that as pi over 2. All right? So what is our c value right now equal to? Our c value is equal to pi over 2. So right here. Go over here. Plug it. Pi over 2. Oh, now you do the question. All right, okay. So right now, what we're going to do is we're going to take all this information and we're just going to plug it in. Here we go. Why? No, she was just joking. She just wanted to be immortalized as funny on YouTube. All right. So here we go. What's our a value? 2. -2. I know you may have gotten a 2. That's okay. We'll figure out if yours is right or not. Here we go. -2 cosine. What's my b value? A half. So instead of half of theta, I'm going to put theta over 2 minus, what's my c value? Pi over 2. Plus my d value of a -1, so I just put -1. And this right here is the final answer that goes with number 9. That's one of the 2 acceptable answers. Actually, there's an infinite number of answers you could put, but we're just going to do 2 different ones. So what I want you to do right now, could you guys hit y equals and type that into the graphing calculator exactly as it appears, if you would please? Well, you could keep sliding it multiple places so that they line up. Okay, we'll kind of talk about that. So we have -2 cosine, and I had what? Theta divided by 2 minus pi divided by 2 minus a 1. And what was our midline? Our midline was what? A negative 1, y equals a negative 1. Now I'm going to change my window real quick. Before I hit graph, I'm going to change my window. My window, I'm going to start, everybody, just so you know where I'm starting, I'm going to start at 0, and I'm going to finish at 5 pi. So what's going to come up on the graphing calculator screen is just from here to right there. That's what you're going to see on the graphing calculator. So we go from 0 to 5 pi. So we go to the window, start at 0. I'm going to type in not 2 pi, I'm going to type in 5 pi. Now this right here, this x scale, if you see 1.57, that's pi over 2, but I'm just going to type it again. Pi divided by 2, in case somebody needs to see the keystrokes. Now my y minimum, I'm going to start at a negative, well, not negative 11, sorry. Negative 3, not 13. Negative 3. My y maximum, I'm going to go all the way up to a positive 1. The reason why I'm going from a negative 3 to a positive 1, in case you're wondering, because I'm here at a negative 3, and I go all the way up to a positive 1. Negative 3 to positive 1. So I'm going to leave that there. Make sure you guys type that. The x max was 5 pi. The x scale is pi over 2. This is negative 3. This is positive 1. So I'm going to hit graph. And there it is. And you'll see my midline. There's my midline, right there. So I'm going to take a picture of this. There's my picture. I'll go back. Can you guys see how this right here, this blue graph is the same as that? It's just scaled a little bit differently on your screen. But these now match each other. Okay? So right now, this is the correct answer. But I want you guys to look at things a little bit differently. Because technically, I could have done something a little bit different. So watch this. I'm going to clear this out. What if I said that the graph actually started here and finished there? So look at this graph. What if I said it goes down and what if this is the way you interpret it? Okay. This is not a negative cosine graph. What is this graph? Positive. So watch this. I'm going to interpret it doing this. Everything else is the same except for this. What's my a value for this blue graph right here? My a value is a positive 2. My b value is still the same. What's my b value? It's still a half. My c value is going to change, but my d value is going to stay the exact same. So let's think about it. What would change if this is normally where it starts, but it shifts over to the left? What would the phase shift be? Negative pi, right? But what would the c value end up becoming? It's becoming a negative pi over 2. If I moved it this distance, right here, this right here would become a negative pi over 2. So here's what I want you guys to do. We're going to write a different graph. We're going to write y equals 2 cosine theta over 2. But instead of saying minus, we're going to say plus pi over 2 minus 1. So this is the other correct answer that you could have gotten if you would have interpreted it as a, not a negative cosine graph like this one looked, but a positive cosine graph. So we're going to type this in the graphing calculator right here. Okay, y equals, let's go down to green so you can see it a little bit easier. Go down to y5 where it says green. Type in 2 cosine x divided by 2, but instead of saying what, minus pi over 2, what are you going to say? What? Plus pi divided by 2 minus 1. Let's take graph. What do you see just happen? Nothing. Oh, I know why you don't see anything. Here's why. You don't have color. So watch this. I'm going to change something real quick. I'm going to type in a negative 1 again. Go down. It should regraph. There we go. There's the blue one. There's that one. Then you see the green. So Don, when you said nothing, that's because yours is black and white, so you see it traced over. So that's actually a good thing. If you see no change, that's a good thing. Look what happens if I would have messed up at one little tiny aspect of the graph. What if I would have forgotten it was pi over 2 and I just put it was plus pi? Look what happens to the graph. There's your first graph. What stays the same? Does the amplitude stay the same? Yeah. Does the midline stay the same? Yeah. What's the only thing that changed? The phase shift. We messed up on the what? We messed up on the phase shift. So, what are your two final answers? This could be your answer, or this could be your answer.